Hey, how is everybody doing? Today we're gonna solve this equation today, which is a second order non-homogeneous equation, differential equation. Well, the to do that, let's find first the homogeneous equation before the particular solution. And to be just to clarify, to get the general solution for these kind of equations, first of all, we in the very end we're just gonna add the homogeneous equation plus the particular solution, the homogeneous solution plus the particular solution. Now, to get the homogeneous, now we set this equation to the left hand to the homogeneous. We set it to equal to zero. We do the math there. You get 0 plus minus 2i. You know, when we get an I form, remember this is how our form going to be, cosine plus sine, C1 and all that. Just plug in the numbers and look what we got here. Look, that I simply as YH of t to mean homogeneous. Look at the solution we have here. We got C1 cosine t squared plus C2 sine t squared. And when we get these kind of equation, if the homogeneous solution have the same math functionality as the particular, we have to multiply the particular by a t. We know the particular here is this equation to the right. This is the homogeneous. See, the homogeneous have the same math functionalities as the same answer. So in order to fix this, when we write the particular, we multiply everything by t. See, y of t, that's the particular solution. We begin our solution here. Y of t equal equal this equation, which is this one, not this equation, not the homogeneous solution. No, just this equation over here. Time, instead of the coefficients, I put a and b, and you'll understand that later when we simplify. And then we times it by t, so we don't keep getting the same answer, because same answer as the homogeneous. Now, it's a particular solution. We need to take the derivative, but how many derivatives we need to take? That's the answer, the question. So as you can see, the homogeneous here, we are only taking up to this second derivative, so, y2 prime. That's the max we need. That's the max we need for this equation. So this is y of t. This is the equation here. This is y of t, y prime of t. Now, we had to take the derivative of this. We used product rule. Real simple, just very long. I got all of this answer, and I factored for later. I grouped it. See the A's and the B's. I grouped them together, cosine and sine. And you will understand why I do that later on. Makes much sense, much more sense in the very end. Now, I do the same thing with the second derivative. Take the y double prime, take the derivative again, just very long. You get all of that. And I also did it again. I factored and grouped them. See? This is just this. I just added all of these here. And then after that, I just grouped the A's and B's together, the coefficients. And now I'll show you why it makes much sense. So when we have now, the first equation here is this one. And we have our set, which is y, which is what we need for this y. And we have y prime now for this y. So now we know what we need. Now, we just plug these numbers back into the original equation. See, this is y prime. This is this equation here is where we got it from here. And then we plug in for the y, this y, we take it, we plug it in here. This is the 4 from the equation. I rewrote it here, I forgot. This is the 4 for the equation. Just plugged in the y we got into it. We multiply, we do the algebra there. The trig here is just much. Now, I do the same thing after I plugged it in. I keep factoring out. I keep grouping and factoring. And now you would know why is that. Now, when I plug in, see, now I got my final equation here. Sine 2 of t negative 4b, because I added these together, and then I factored them, plus cosine 2t of 4a. Now, it's much easier when I get the coefficients that I solved for and the coefficients I was given, and now I would equal them to each other. Now I know for b is negative b4, I got it from here, equal to 11, which is from the original equation over here. And the same thing, and notice here there's no coefficient, but we know there's always a 1. So that's what I plugged in here, equal 1. Now I'll solve for b and a. Now I just plug in b and a back to the equation, y of t. And that's how it looks. Now I just add the homogeneous equation with the particular equation to get the general solution. And that's how the general solution look like. C1 cosine 2t plus C2 sine of 2t. That's the homogeneous, plus, my bad, minus 11 over 4t sine 2t plus 1 over 4t cosine of t. So it's all related. This is all we need. We just need to find out the homogeneous is real easy to find out. Just set them equal to 0 and find that out. And the particular, we just need to watch out when we get what's the answer for the homogeneous equation. If it's the same functionality as the particular, we need to multiply by a t, or we would go in a loop. And that's it. That's really it. We just find these number, we take in the equations, and then we plug them back in, and we factor to make it very easy on ourselves, or this could go very long if we haven't factored. And that's most of it. Thank you.